There is a particular kind of institutional decision that shapes the outcome of conflicts long before the first engagement begins. Not the choice of where to advance or when to commit reserves, but the quieter, earlier decision of what tools to place in the hands of ordinary soldiers. In the Pacific War, one such decision, made years before the conflict started, would define the operational balance between American and Japanese infantry at every level of engagement, from isolated jungle outposts to large-scale coordinated operations. That decision was the adoption of the semi-automatic rifle. This video is presented for historical and educational purposes only. By the time American forces arrived on Guadalcanal in the summer and autumn of 1942, the United States Army had already been issuing the M1 Garand as its standard infantry rifle for 6 years. The Imperial Japanese Army, by contrast, had entered the war still relying on bolt-action rifle designs rooted in the early 20th century. This gap in small arms technology would reshape every tactical encounter between the two forces throughout the Pacific theater, influencing not only individual engagements, but unit-level doctrine, logistical planning, and the operational tempo of entire campaigns. Understanding why this gap existed and why it proved so consequential requires looking at both systems on their own terms. The M1 Garand had its origins in a specific institutional lesson. After the First World War, American military planners, drawing on the experience of the Western Front, concluded that individual infantry firepower needed to increase substantially. The bolt-action rifle, however well made, imposed a fundamental mechanical constraint on any soldier who carried it. After each round, the firer was required to manually cycle the action through 4 distinct movements, rotating the bolt handle upward, drawing it rearward, pushing it forward, and rotating it back down to lock the chamber. The entire sequence interrupted the shooter's sight alignment and required deliberate physical effort under any conditions, including stress, fatigue, mud, and darkness. John Garand, a Canadian-born designer working at Springfield Armory from 1919 onward, spent 17 years developing a solution. His gas-operated rotating bolt system tapped a small portion of propellant gas from a port near the muzzle, using that pressure to drive an operating rod that cycled the action automatically after each trigger pull. The shooter maintained their firing position throughout. The spent case was extracted and ejected mechanically, and a fresh round was chambered without any manual input. The M1 was formally adopted on January 9, 1936, making the United States the first nation to field a semi-automatic rifle as standard infantry equipment. The rifle chambered the .3006 Springfield cartridge, firing a 150-grain projectile at approximately 2,800 feet per second, generating around 2,650 foot-pounds of muzzle energy. It fed from an 8-round en-bloc clip, inserted from above into a fixed internal magazine. A trained soldier could deliver between 40 and 50 aimed rounds per minute, reloading when the clip was exhausted and automatically ejected required approximately 3 seconds. Under practiced conditions, production was organized at scale. Springfield Armory and Winchester Repeating Arms Company were the primary manufacturers. By January 1944, Springfield Armory alone was producing 1,000 rifles per day. Total American production of the M1 between 1936 and 1945 reached approximately 5.4 million units. Quality control was rigorous throughout. Rifles were required to group within 5 inches at 100 yards before leaving the factory, and parts were manufactured to tolerances that ensured full interchangeability between rifles from different production runs and different manufacturers. Japanese infantry rifles in 1941 traced their lineage to a different set of priorities. The Type 38 rifle, adopted in 1905 and named for the 38th year of the Meiji era, had been designed by Colonel Nariakira Arisaka and refined over subsequent decades. It fired the 6.5 x50 mm semi-rimmed cartridge, launching a 139 grain projectile at approximately 2,500 feet per second. Its barrel measured 31.4 inches, exceptionally long for an infantry rifle, which contributed to accuracy at extended range but created significant handling constraints in dense vegetation and confined spaces. The internal magazine held 5 rounds, loaded via stripper clip. The Type 99, introduced in 1939, addressed some limitations of the Type 38. It chambered the more powerful 7.7 x5 8mm cartridge, firing a heavier projectile at roughly 2,400 feet per second with approximately 2,300 foot-pounds of muzzle energy. Its barrel was shorter at 25.9 inches, making it somewhat more manageable in the field. Early production examples incorporated notable engineering refinements, including chrome-lined barrels, among the first military rifles to feature this treatment, folding anti-aircraft sights, dust covers, and integral monopods. Both rifles operated on the same manual bolt-action principle. After each round, the firer rotated the bolt handle upward, drew it rearward, pushed it forward, and rotated it down to lock. The cycle required 2 to 3 seconds under ideal conditions, considerably longer under field conditions, involving physical exertion, poor visibility, or operational pressure. A well-trained soldier could deliver approximately 15 rounds per minute in sustained operation. The Arisaka action itself was structurally sound. Post-war testing confirmed it was stronger than comparable actions on American, British, and German service rifles. But structural integrity was not the limiting factor. The constraint was mechanical, the requirement for manual bolt operation in each firing cycle, and no refinement of materials or engineering could alter that fundamental characteristic. When the 164th Infantry Regiment, a North Dakota National Guard formation, arrived at Guadalcanal on October 13, 1942, they were the first United States Army unit to enter offensive ground operations against Japanese forces in the Pacific. They brought with them a full complement of M1 Garand rifles, arriving alongside Marine units that were still predominantly equipped with M190 3-Springfield bolt-action rifles. During the engagement at Henderson Field on the night of October 24 to 25, the operational difference between the two systems became measurable in real terms. Japanese forces initiated a large-scale coordinated advance against the American perimeter in the early hours of October 25th. The operation was carried out by experienced infantry formations with practiced coordination and genuine tactical discipline. What the advancing units encountered, however, was a defensive line capable of generating a volume of sustained, aimed output that pre-operation estimates had not fully accounted for. An American rifle squad of 12 men, equipped with 10 M1 Garands and 2 Browning automatic rifles, could sustain between 400 and 500 aimed rounds per minute in defensive operations. A comparable Japanese squad, operating with bolt-action rifles, could sustain approximately 150 to 180 rounds per minute under maximum effort conditions. At company level, the disparity scaled proportionally. Company G of the 164th Infantry Regiment is recorded as having expended approximately 30,000 rounds of .3006 ammunition across a single night of defensive operations, averaging roughly 150 rounds per man, while maintaining its position. The semi-automatic action produced operational consequences beyond raw output rate. Because the M1 cycled automatically, the shooter maintained cheek weld and sight alignment between rounds. Target reacquisition was faster. Follow-up rounds could be directed more accurately. In low visibility conditions where situational awareness was reduced and response windows were narrow, this continuity of firing position had a measurable effect on the practical accuracy and consistency of the defensive system as a whole. For advancing forces operating with bolt-action rifles, the mechanical asymmetry ran in the opposite direction. After each round, manual cycling required gross motor movement of the arm and shoulder, interrupting firing position, disrupting sight alignment, and demanding deliberate mechanical attention at precisely the moment when situational awareness was most critical. Under sustained operational pressure, the cognitive and physical demands of bolt operation compounded considerably, reducing both output rate and positional stability. The logistical dimension of the comparison added a further layer of operational complexity for Japanese forces. American units in the Pacific operated with a single rifle cartridge across all individual and light automatic weapons. The .3006 Springfield round was common to the M1 Garand, the M190 3 Springfield, the M1918 Browning automatic rifle, and the M191 machine gun. Supply chains managed one cartridge type for the entire category of infantry small arms. The Lake City Army ammunition plant alone was capable of producing 200 million rounds annually by 1943. Japanese forces maintained two separate rifle cartridges in simultaneous field service. The 6.5x50 mm for Type 38 rifles and the 7.7x5 8mm for Type 99 rifles. Documented supply failures occurred as a direct result of this dual system. During operations on Guadalcanal, the 23rd Infantry Regiment received ammunition in the incorrect caliber for their issued rifles, rendering both the weapons and the supply consignment temporarily non-operational. Similar mismatches were recorded during operations in the Philippines and on isolated island garrisons throughout the theater. In an operational environment already characterized by extended and fragile supply lines, ammunition misallocation directly affected unit readiness at critical moments. Japanese manufacturing capacity presented additional constraints. Despite producing approximately 3 million Type 38 rifles across multiple arsenals between 1905 and 1945, and roughly 3.5 million Type 99 rifles between 1939 and 1945, Japan never achieved the standardization and parts interchangeability that characterized American production. As the war progressed and resource pressures intensified, quality control in Japanese rifle production deteriorated markedly. By 1944, refinements that had distinguished early Type 99 production, chrome-lined barrels, precision-fitted stocks, detailed metalwork, had been eliminated entirely. Late production rifles showed rough machining, simplified sights, inferior materials, and reduced finishing standards. The manufacturing infrastructure that might have supported a transition to semi-automatic production simply did not exist at the scale required. Japanese military leadership recognized the output disparity, though the institutional response remained constrained by both material limitations and doctrinal tradition. A November 1942 assessment by Lieutenant General Harukichi Hyakutake, commanding the 17th Army on Guadalcanal, noted that American rifle output exceeded expectations in both density and accuracy, and that Japanese formations were unable to establish operational parity and sustained output even when holding numerical advantage. The recommendation was to shift emphasis toward night operations and infiltration approaches, designed to reduce the operational distances at which American semi-automatic systems could be most effectively employed. By 1944, formal tactical guidance issued to defenders of the Mariana Islands acknowledged that American small arms output created conditions during daylight that made coordinated movement operationally costly, and directed that organized operations should occur primarily at night or under adverse weather. The tactical adaptation was genuine and, in some contexts, effective, but it represented a reactive adjustment to a material disadvantage rather than a resolution of the underlying systemic problem. Japan did initiate development of semi-automatic rifle designs during the 1930s, including gas-operated prototypes examined within the development programs of that period. Practical progress remained limited, however, as available design and manufacturing resources were directed toward aircraft, naval construction, and other programs considered higher priority. When Japanese engineers eventually undertook a direct reverse engineering effort based on captured M1 Garand rifles, producing what became known as the Type 4, they demonstrated a clear understanding of the design's operational advantages. The program produced components for approximately 250 rifles, with between 100 and 125 complete weapons assembled before the end of the war. The industrial capacity required for meaningful production at scale was never available. The operational pattern established at Guadalcanal in late 1942 repeated itself, with local variations across the subsequent campaigns of the Pacific Theater. At Saipan in June and July of 1944, at Peleliu in September, at Iwo Jima in February and March of 1945, and through the extended Okinawa campaign from April to June of 1945. The structural relationship between American semi-automatic output and Japanese bolt-action output remained a consistent factor in tactical outcomes. Japanese defensive doctrine evolved substantially across this period, moving away from massed coordinated advances and toward defense in depth, using prepared positions in difficult terrain. This adaptation extended engagements and increased the operational cost of each island campaign. But even from fortified defensive positions, the mechanical output disparity continued to influence the balance of each direct engagement. American units could generate sustained, aimed output sufficient to limit defensive observation and response capacity, enabling positional movement that would have been considerably more difficult against defenders with equivalent individual output capability. The M1 Garand's mechanical reliability in the environmental conditions of the Pacific Theater contributed directly to its operational consistency. The gas-operated action functioned under sustained fouling, in tropical humidity, in volcanic ash, and in the salt air characteristic of amphibious approaches. This reliability was not incidental. It reflected the 17 years of refinement that preceded formal adoption, including extensive evaluation under varied environmental and operational conditions. The comparison of these two systems ultimately reflects something broader than the characteristics of any individual weapon. It reflects the relationship between industrial capacity, institutional decision-making, and operational outcome. The United States had recognized in 1919 that semi-automatic infantry rifles represented the direction of future development. It invested nearly 2 decades in design, evaluation, and production infrastructure. By the time the Pacific War began, the industrial framework for producing, supplying, and maintaining the M1 Garand was fully established. The rifle was not an improvised wartime response. It was the product of a long-term institutional commitment to a specific operational capability. Japan entered the conflict with a rifle designed for the conditions of the Russo-Japanese War of 1904–05, a conflict in which Japanese forces had performed effectively against an opponent whose material limitations were different in kind from those of a fully industrialized American military. The institutional lessons drawn from that earlier success reinforced existing doctrinal assumptions in ways that made it more difficult to assess how thoroughly the conditions of infantry engagement had changed in the intervening decades. What the Pacific War demonstrated, engagement by engagement and island by island, was that individual output capacity functioned as a genuine operational multiplier across every level of tactical organization. A squad equipped with semi-automatic rifles could sustain output, reposition, and maintain positional pressure simultaneously in ways that bolt-action equipped formations could not replicate. A company holding a defensive perimeter at night could generate the sustained output needed to disrupt coordinated advances. Each rifle, in that specific operational context, was not merely a tool for individual use. It was a component of a system, and the system's overall effectiveness depended directly on the rate at which each of its components could generate accurate, sustained, mechanically consistent output. The M1 Garand gave every American rifleman the individual output capacity of roughly 3 soldiers equipped with bolt-action weapons. Across millions of individual engagements, across every contested position, jungle perimeter, and fortified ridge of the Pacific Theater, that arithmetic became one of the defining operational realities of the war, a consequence not of any single engagement, but of a production decision, a design investment, and an institutional commitment made nearly 2 decades before the first round was ever chambered on Guadalcanal.